So I want to start with a question like this, and suppose we were interested in trying to find the slope of this curve at a particular x value. So we should have some general idea of what the graph is here, right? We have a vertical asymptote at -1, and so I know that there's a horizontal asymptote at 0, and if x is a negative number or a positive number, I should kind of know the behavior. So I can kind of think of some numbers here, and I could probably come up with, okay, the graph has to be then something that looks like this. So if I'm looking for like how steep it is at a certain moment, that's an instantaneous rate of change. So really then what I need to calculate is the limit as h goes to 0 of the difference quotient. Remember, the difference quotient here is a slope. And I always like to write it this way because I can see it's a slope. And then, so if I just then use the function that I gave and try to substitute these pieces in, I have the limit as h goes to 0 of 1 over x plus h plus 1 minus 1 over x plus 1 all over h. And so, so now it's just a matter of trying to simplify this. We know that the pattern is going to be that this should be connected to a notion of this hole at this value when h is 0. And so right now, if I put a 0 into the expression here, I'm going to get 0 over 0. But that doesn't mean that the limit doesn't exist, right? Because that really just means that it's an indeterminate form. It could be lots of different things. And so really, we just need to simplify it. So maybe if we look above here, really, why don't we just maybe make some common denominators in that portion? So we'd have the limit as h goes to 0 of x plus 1. I'm going to go ahead and, well, let me just write it separately. X plus h plus 1 minus 1 times x plus h plus 1. So I didn't really need to write that one over I missed a piece here. I'll go ahead and put it this way. I was thinking about putting it another way. So thinking about multiplying this one by x plus 1 over x plus 1, this one by x plus h plus 1 over x plus h plus 1. And this is still all over h. So then as you're simplifying this, don't cancel these back out. Like you're putting it there to combine it together. So we would have the limit as h goes to 0 of x plus 1 minus x plus h plus 1 over x plus 1 times x plus h plus 1. Now I could say over h, but I'm actually then just going to think about that as a h over 1 and multiply this by 1 over h. And so when you look at this numerator here, these x's are canceling, the 1's are canceling, there's a minus h. So that minus h is going to cancel here with this h, leaving you with not a 1, but a minus 1, right? There's still that negative right here. So I'd have negative 1 over x plus 1, x plus h plus 1. And now, this is that notion of the hole, this h that's canceling out. So I can now evaluate this limit. This would be like that extended function where the point is now filled in for that removable discontinuity. So this then would be minus 1 over x plus 1 quantity squared. And so then here's what we have found. I was wanting to find a slope at a specific value. And so now I have a formula here that will find the slope at whatever x is. How do I know it's at whatever x is? Because remember then we would have 2 points on some graph. If that's x and that's x plus h, if h goes to 0, then that is squeezing down and these points would be moving together. So if I go back here to my really rough sketch, and if I would say find the slope of this graph when x equals 0, so thinking about what's going to happen there. So when x is 0, this answer is minus 1. So then the slope of the tangent line at x equals 0 is minus 1. And so really what that's saying is that the slope of that line would be minus 1. So there's a quick example here, another one in terms of using this idea in 2.4.